All right, we are reviewing for our Chapter 8 test. How exciting, we've made it this far. So this is what the test will look like. And then these questions are different numbers, but same processes. So I'm gonna make sure you can do this review. You should have already tried it and answered everything you possibly can. And now you're just checking your answers, or if there's one you're stuck on, you're looking to see how to do it. But don't watch this first. That won't help you prepare for the test. All right, when we add radicals, and I want to underline this, simplified radical form for these four answers, okay? Simplified radical form. When you add radicals, they have to match. So those two are both square root of 13. I can put them together. And what we do is take the coefficients, add them together, so 10, but then the square root of 13 doesn't change. It stays the same. Same thing we'll do with the square root of 17s. Okay, we want to put these two coefficients together, so 7 minus 3 is 4 square root of 17. Square root of 17 didn't change, remember, with adding and subtracting. Now this is way back from kind of in Chapter 7 we talked about these, so this is kind of review of Chapter 7 stuff. Okay, multiplying. Multiplying, you multiply the outside parts together and then you multiply the inside parts together. So since 5 is on the outside, 11's on the outside, we'll put those two together. On the inside, 14 and 7. And you want to check and see if there are any doubles under the radical sign. And there are. If I break my 14 down into 2 times 7, I have 2 7s. That means there's a perfect root there, a perfect square, and I need to take that root out. The 2, though, does not have anybody. So on the outside, it was 5 times 11, and now times 7 under the radical is 2. And let's put that into one number. 5 times 11 times 7, 385. Square root of 2. Okay, remember, we don't want to get decimals for these. It's simplified radical form for these first 4 questions. Okay, no decimal. Number 3, rationalize the denominator. No square root in the denominator. So what we have to do is multiply it by something that makes it so that the denominator is no longer a square root. And you remember, if there were 2 11s, we'd have a double and it would pop out. So we'll use that. We have to multiply by the same thing on the top so that this is just the value of 1. We're just multiplying by 1. All right, numerator times numerator, denominator times denominator. We have 11 and an 11. That's a double. So 11 can pop out. 9 squared of 11 on the top. And that 11 pops out. There's nothing left under the radical sign. And that's exactly what we needed that to do, so that it would be in simplified radical. No radical in the denominator. All right, next one, find x. All right, this looks like a right triangle, so we can use Pythagorean theorem. We have to figure out which side is C. It's always that side opposite the right angle. So let's call this guy A, this guy B. We'll say A squared plus 9 squared equals 11 squared. Make sure you got your hypotenuse all alone on one side. That's important. Won't get the right answer if you don't. So A squared plus 81 equals 121. Let's move that. A squared equals 40. And then we don't want A squared. We want to know what A is. So take that square root, and A equals, okay, the square root of 40. Now remember, this is in the section where we have to write it in simplified radical form. So don't go for a decimal on this one. 40, we'll have to do the tree and break it down and see what pops out. I'm going to put it over here. If I break that down into 2, 20, 2, 10, and 2 and 5. So there is a double. He needs to pop out. But then this 2 and this 5 don't have a companion, so they stay inside. 2 pops out, and underneath we'll put these back together. 2 times 5 is 10. Okay, that is simplified radical form. And all 4 of those first answers on your test you won in simplified radical form. I think from here on out, decimals will be okay. All right, determine whether each set of numbers could be the measures of the sides of a triangle. If so, classify it as acute, obtuse, or right. So remember what the three things are. I'm going to write them over here. A squared plus B squared, if it equals C squared, it's a right triangle. If we have A squared plus B squared is greater than C squared, that one is acute triangle. Do that. And if we have A squared plus B squared is less than C squared, that is obtuse triangle. Okay, so let's make sure you've got that there, and you've got to think about that. Okay, let's try them. So we've got 3 sides to a triangle, 50, 120, 130. Always the biggest one is the C. So 50 squared plus 120 squared. I'm going to put a question mark. Is that, or what is the relationship between that and 130 squared? 50 squared plus 120 squared. Ooh, 16,900. That's a big one. And let's try 130 squared. Oh, look. 16,900. Those are equal, which means that that is a right triangle. So I'm going to put a right triangle here. Now to get all the points on that question, you got to show some work, show how you know it's true, and then give that answer. Okay, next one. Biggest side is C. 40 squared plus 72 squared. Is that, or what is that relationship to 75 squared? Let's check. 6,784 and 75 squared, 5,625. Okay, those are not equal, and 6,000's bigger, so we'll do this. That means it is an acute triangle. There's 2 little sides. Okay. Last one. And there will be one like this on the test. There's one with a square root, just to see if you know how to shake that up. And this one, it is the C value. That is the biggest number there. Now, how could I know that for sure? If I did the square root of 5,776 in my calculator and hit enter, it would give me a decimal value. Oh, look at that. It's a perfect square. And I know that 76 is bigger than these other 2 numbers, so he is the C. He is the C value. Okay, so let's do, is 32 squared plus 60 squared, what's that relationship to? I'm going to do this, the square root of 5,776 squared. I already know what that number is since I already put it in here in my calculator. Oh, wait. Yeah. Okay. 32 squared, let's see. 32 squared plus 60 squared, 4,624. And then I guess what I need to do there, if I'm taking the square root of it and then I'm squaring it again. So actually, I could either do this 76 squared, or I could say I'm squaring a square root. Those guys cancel each other out. Either way, however you want to think about that. The square root of that is 76, and when I square 76, it's that same number that was under the square root. Now, which one's bigger? That would be 5,776. That is this situation, obtuse. Obtuse triangle. Okay, that's the front side. Let's turn it over. And on the back. Okay, now we're launching into some of the trig functions that we did. And I'm going to write up here Sohcahtoa. So sine, opposite hypotenuse, cosine, adjacent and hypotenuse, tangent, opposite and adjacent. We might need those. Oh, wait, we're not going to need those. These are special triangles. Okay, we don't need those for special triangles. These are the ones that you just need to have memorized what the pattern is for special triangles. When it is a 45, 45, 90, then the pattern is that the legs match and the hypotenuse is whatever that leg value is times the square root of 2. So I'm going to draw a little sample 45, 45, 90. So that's our 90 and our 45. X, this is the matching. The legs have to be the same. And then the hypotenuse is x times the square root of 2. Okay. So it says, find the value of x and y. X equals, here's our x value. So we need to take the 13 and multiply it by the square root of 2. That's what that would be, 13 times the square root of 2. So if you've memorized the relationships here, that's not even that tough of a problem, right? We're just combining it with the square root of 2. We also need to figure out y. And we said the two legs are always the same. So if that leg is 13, this leg is 13. Those will be the two answers for the 45, 45, 90 problems. Let's look at this one. So we've got 25 times the square root of 2 here. And then we need to figure out what the two legs are, x and y. And they'll be the same number. So since we multiplied this number by the square root of 2 to get the hypotenuse, we could divide, I don't know why I wrote 12, 25 square root of 2. We'll divide it by the square root of 2, boom, boom, and we're just left with 25. And they have to be the same. Okay. All right, let's try a 30, 60, 90. Do you remember how those relationships work? Let me draw 30, 60, 90 here. I'm going to do it this way. So this is a right triangle. This is the 30. This is the 60. And you always want to have that shortest side. He's like your anchor. If you know the shortest side, you can find both the other sides. To get to the hypotenuse, this side, hypotenuse is 2 times that short side. So it's always this 2x to get to there. And then the long side, I think we'll call that, right? The short side, the long side, we have to take the short side and multiply it by the square root of 3. And that's the relation. So you want to make sure you get that short side first, and then you can find the hypotenuse by doubling it. You can find the long side by multiplying it by the square root of 3. Okay, let's look at this triangle. Here's our 30. This is our short side, it's 12. So that's like this piece is 12. So now to find the hypotenuse, what did we do? We doubled it. So our x value would be 24. And I'm going to write a 24 right here. Boop, boop. And then the long side of the triangle, how did we get that one? We took the short side and multiplied it by the square root of 3. So 12 times the square root of 3. 12 times the square root of 3. Okay. Okay, let's try another one. Okay, let's look at this number 11 then. So we've got, oh, they didn't give us the short side. They didn't give us the long side. They gave us the hypotenuse, which is 23. So to get to the one side, if this is 2 times x, and we want just plain x, we'll have to divide that. So x is equal to 23 divided by 2. And 23 divided by 2 23 divided by 2 is 11.5. So our x value is 11.5. And now we got to get to y. So that is the long side where we take x and multiply it by 3. Y equals 11.5 times the square root of 3. Okay, got it. Let's keep going. This is where we need Sohcahtoa. Okay, I jumped the gun before, but this is where we actually need it. So it says find the sine of b, the cosine of b, and the tangent of b. Express as a fraction, so you don't need to take the time to put in your calculator and get a decimal. And then the sine of a, cosine of a, and the tangent of a. So let's use, first it's b. This is our anchor spot. If he's the angle we're looking at, then this 36 is the opposite side, and 15 is the adjacent side. 39 is the hypotenuse. So let's do sine is opposite over hypotenuse. I'll put that right here. Opposite 36, hypotenuse 39. Cosine of b, so adjacent over hypotenuse. Adjacent is 15, hypotenuse is 39. Tangent, opposite over adjacent. So 36 over 15. Okay, we did it. Now we need to do this for angle A. So get rid of all that. Different hypotenuse would stay the same, but we'll get rid of opposite, we'll get rid of adjacent. Hypotenuse will not change. This is our anchor angle. Opposite is 15. Adjacent is 36. So let's do this. Sine, still opposite over hypotenuse. So opposite is 15. Hypotenuse is 39. Cosine. Adjacent is 36. Hypotenuse is 39. And then tangent. Opposite is 15. Adjacent is 36. Okay, you guys got that? I know you're doing it. All right, let's pop to the next page. That was question 12. This is question 13. Okay. Here again, we need those trig functions, those trig ratios. And it says find the missing side measure using those trig ratios. Nearest tenth. Okay, this is the missing side y. And he is the hypotenuse, right? Here's our anchor angle, and so we have the side right next to him, which is adjacent. We have adjacent and hypotenuse. Which trig function goes with that? Adjacent and hypotenuse. We need cosine. Cosine of 72 is equal to adjacent over hypotenuse. Adjacent over hypotenuse. Hypotenuse we don't know. That's what we're solving for. Okay, we got to get him out of the denominator. So multiply both sides by y. Y times the cosine of 72 equals 46. And then if we're solving for y, divide both sides. And now we have y equals 46 divided by the cosine of 72. Grab a calculator, right? Let's see what we get. 46 divided by cosine 72. Did you get 148.9? 0.9. We're rounding up to the 10th there. Okay. Yes. Awesome. Let's do another one. This is, so we have a hypotenuse. This is our anchor angle, and that guy is opposite the anchor angle. So if we have opposite and hypotenuse, sine, we need to do a sine. Sine of 25 equals opposite over hypotenuse. We're trying to solve for y. Multiply both sides by 46. 46 divided by 46 is 1. So we have 46 times the sine of 25 equals y. Let's throw that in. 46 sine of 25. Did you get 19.4 as that side y? Awesome. Okay, those are missing side questions. We also have some missing angle questions. Missing angles. Here's our missing angle. Here's our missing angle. Okay. So if this is our anchor angle, this is the hypotenuse, and this is the adjacent side. Which trig function has adjacent and hypotenuse? Yeah, cosine, and we'll call that x. Cosine of this angle equals adjacent over hypotenuse. Now remember, when it's missing the angle, we have to do the inverse. We have the answer and we have to like undo it to find what angle that started with. So we do the inverse of the cosine. And then we have to take the answer that we had, and that will give us the measure of that missing angle. Still putting it in the calculator though. So second cosine, make sure that -1 pops up. We're doing inverse, 47 divided by 63. Did you get 41.8 degrees for that angle? Equals that measure of, it's actually x degrees, so we'll just say it equals x. Done. Okay, let's do another one. This is like our little x right here. We have opposite and we have adjacent. We don't use the hypotenuse. They didn't give us anything. So which function uses opposite and adjacent? Yeah, tangent of x. Opposite over adjacent. And we don't have this. We need to undo it. We have the answer. We got to find where it started. So tangent to the -1, the inverse of this answer gives us that measure of angle x. Let's throw that in the calculator. Tangent of 73 divided by 60. Did you get 50.6 degrees for that missing angle? Awesome. All right, let's keep going then. So this says solve the right triangle. Remember when we did this, you find all three angles, all three sides. Solve it, measure, okay, to the nearest tenth. So let's put in what we've got. Angle y is the 90 degrees, so that one's done. XY is 37. YZ is 29. So we don't have the hypotenuse, which would be like the C. We can work on that. And then we'll have to use some trig functions to get our x and our z angles. What do you want to do first? I think I'm going to work on, oh, I get to go home. I'm going to work on this one, the measure of angle x. So here's x. If he's the one I'm looking at, then this side's opposite, this side's adjacent, and it looks like I'm doing a tangent function then, right? Tangent of some value I don't know, opposite over adjacent. Okay, and when we're missing the angle, we have to do inverse. 29 over 37, and that will give us the measure of angle x. 29 divided by 37. Okay, looks like it is 38 point, if we're rounding to 1 degrees, measure of angle x. I'm going to put a little box around that so I can work on a different one without getting confused. 38.1 degrees. All right, let's try to find z then. I want to erase this, erase this. If this is the anchor I'm working from, now this side's opposite, this side's adjacent, and I still want to do tangent. The tangent of z is opposite over adjacent. got to do the inverse. Tangent to the -1. Oh, I wrote adjacent? Oh. Shoot, 29. Okay, over 29 equals 37 divided by 29. All right, did you get 51.9 right there? Degrees. 51.9. And you know, it's always a good idea, once you've got the 3 angles, add them and make sure it's 180. 38.1 plus 90 plus 51.9. Let's see. Oh, good. Oh, good. Then you feel pretty confident that you got that right, because there should be 180 degrees in your triangle. Okay. The last side, we'll use Pythagorean's theorem to find that side. We said already that the hypotenuse is the one missing. So I'm going to make this A, this B. 37 squared plus 29 squared equals C squared. Let's add those. 29 squared. So this is 2210 equals C squared. But I just want C square root. What is the square root of 2210? 47 point, we're going to say 0. 47. Almost exactly. 47. 47. Done. All right. We solved that triangle. All right, let's turn this over. We are so close to being done. There's something weird on my screen. Get rid of that. Okay. My computer's slow. Okay, we've got angle of elevation and an angle of depression. And remember, elevation is when you're looking up from some horizontal line. The angle of depression is when you're looking down from some horizontal line. So let's see. The angle of elevation of this staircase is 33 degrees. The distance traveled as you walk up the stairs is 29 feet. What is the horizontal length of the bottom of the stairs? Okay, more trig, right? Here's our angle of elevation. This is the horizontal line. And then this is the elevation up 33 degrees. If this hypotenuse is 29, and then this would be the adjacent side to the angle, what trig function do we need for adjacent and hypotenuse? Sounds like a cosine, right? Cosine of 33 is adjacent over hypotenuse. We're solving for x. Multiply by 29, multiply by 29. So we need to put this in our calculator. 29 times the cosine of 33. All right, did you get 24.3? Good, equals x. And it's a word problem. We'll have to put some words back in there. 24.3 feet for the bottom of that staircase. Awesome. One more, it's depression, the angle of depression. So we're looking down now. From your horizontal view on the bleachers, here's the horizontal line, is 32 degrees. If your seat is 96 feet above the stage, what is the actual distance? So the hypotenuse of that triangle. So do remember that alternate interior or congruent, that means this is also 32 degrees. If we want to use this triangle, that helps us. You could also say, well, this is a 90-degree angle, subtract 33, and what do you have here? You could do that. Both ways work. So I'm going to use this 32. I've got the opposite side, and I'm looking for the hypotenuse. So opposite, hypotenuse, that sounds like a sine problem. The sine of 32 degrees, opposite over hypotenuse. I'll put a D there since they did. You could use an X, you could use anything. Multiply both sides by that. So D times the sine of 32 equals 96. I want D by itself, so let's do some dividing. And what do we get? 96 divided by the sine of 32. 181 point, we'll round that to 2. 181.2. I'm going to put feet from your seat up at the top of the bleachers down to, was it a stage? The stage below. Okay, and then there will be a bonus question that you'll want to take a stab at that and try to get those 4 points. Okay, that's our review. I will see you guys later.